Namaskar. The topic of the lesson today is on the topography of ocean floors. Seas and oceans are the blue beauties of the planet Earth. Oceans are vast bodies of saline water occupying the great depressions on the earth. They belong to the hydrosphere and cover almost 97% of it. Oceans cover 361 million square kilometers of the earth's surface. The volume of water is 1.37 billion cubic kilometers. They are extensive, exhaustive and exploitable marine resources. Very huge masses of water with varied dimension exist as oceans. Onshore and offshore marine ecosystems are characterized by very distinct features with unique fauna and flora. They hold many marine habitat and contain a lot of natural resources. When we move towards the seashore, we may see the beaches with splashing tides and dancing waves. There is a bluish water body seen as a straight flat plane denoting the sea level. Waves coming towards the land break while nearing towards the coast and subsides while touching the beach. The coastline is the boundary between the land and the ocean. The surface beneath the oceanic waters is characterized by a lot of relief features. The structure, configuration and relief features of the oceans also vary from one ocean to the other. All major oceans and seas vary in their sizes, shapes, depths, aerial extension and in all other aspects like temperature, density, salinity and chemical composition. The marine geological, chemical and biological information and data are also very vast and useful for studying and analyzing the oceans. On the basis of bathymetry and other studies, the morphology of ocean basins have been classified. They have been classified into three important divisions. One is the continental shelf, the next one is the continental slope and the third one is the deep ocean basins. The continental shelf and the continental slope belongs to the continental margin regions. The deep ocean basin consists of the abyssal plains, abyssal hills, ocean trenches, mid-oceanic ridges and the deep ocean floors. All these are all interesting features about the ocean floors. Hence, in this episode, the following aspects are going to be seen by us: historical ocean explorations, continental shelf, continental slope and submarine canyons, features of deep ocean basins and mid-oceanic ridges. Let us see the first one, the historical ocean explorations. Ever since people started sailing the oceans, attempts have been made to map them. Ptolemy has prepared the oldest map, which is an example for all of us today. Modern knowledge of the ocean began with the voyages of discovery of Christopher Columbus, Vasco da Gama and Ferdinand Magellan, and many others also have worked for that. They laid the foundation for global trade routes stretching from Spain to the Philippines in the early 16th century. The routes were based on a good working knowledge of the trade winds, the westerlies and the western boundary currents in the Atlantic and in the Pacific. The early European explorers were soon followed by the scientific voyages of discovery led by the others like James Cook and Charles Darwin. Sir James Clark Ross and Sir John Ross, all of them have surveyed the Arctic and Antarctic regions from the Victory, the Isabella and the Erebus. These three voyages are very important explorations. Edward Forbes studied the vertical distribution of life in the oceans. Others have collected oceanic information based on observations and produced a lot of useful charts, including the Edmund Halley, who charted the trade winds and monsoons, and Benjamin Franklin, who charted the Gulf Stream. Slow ships of the 19th and 20th centuries gave way to the satellites, drifters and autonomous instruments towards the end of the 20th century. Topography refers to the elevation of a land with reference to the sea level. Bathymetry refers to the depth of water column below the sea level. Bathymetry refers to the depth zones of the ocean basins depicted as charts and maps prepared using depth sounding techniques. The words bathos means depth, metry means measurement. The measurement of ocean depths in the Mediterranean Sea was started as back as 85 BC. In 1872, the HMS Challenger expedition was the first to use fully the methods of bathymetry. The Challenger was the first vessel used to systematically record the information about all the oceans, including their depths, circulations, temperatures and the organic life. This has been done except the Arctic regions. In 1925, the Meteor, one of the oldest South Atlantic Ocean expedition, used echo sounders for depth measurements using sound waves. In 1950s, the sophisticated precision depth recorders were invented and used for these mappings. Ocean bathymetry was used as the basis to conduct all the expeditions and experiments in different depth zones of the oceans. The precision depth recorders of 1950s and the multi-beam echo sounders helped to efficiently and accurately map the ocean relief features. A hypsometric curve is a graphical representation of the area of the Earth's surface above any given elevation or a depth. This may be above the sea level or below the sea level. Great ocean bathymetric mapping, marine explorations and expeditions have provided enormous data and information about the world's oceans. The world's ocean floor, as mapped by Bruce Heezen and Mary Thorpe, is presented in this map. This map shows the spreading zones, subduction zones and their trenches. Oceanic dimensions range from around 1500 kilometers for the minimum width of the Atlantic to more than 13,000 kilometers for the north-south extent of the Atlantic and also the width of the Pacific. Typical depths are only 3 to 4 kilometers. So, horizontal dimensions of ocean basins are 1000 times greater than the vertical dimension. The amount of land above the sea level is very much less than the volume of the sea. Satellite oceanography is a milestone in ocean analysis. The launching of CSAT in 1978, the first oceanographic satellite, revolutionized the measurements of physical properties of the ocean. Within a few years, the sea surface temperature, wave height, variations in sea surface contours, ice cover, chlorophyll content and other parameters were measured and reported almost instantly from the satellites. Satellites now observe the oceans, air and the land. Thousands of drifters observe the upper 2 kilometers zone of the oceans. Data from these systems, when fed into the numerical models, allows us to study the Earth and its oceans very clearly. Let us see the distribution of various features in the continental shelf region. A schematic profile of the continental margin to the deep sea shows the following zones. The coastal plain is the first part of the water's edge. It includes the beaches, mainly covered by unconsolidated sediments. These are subjected to wave energy that moves these sediments by converging on the headlands. The inner and outer continental shelf is the second part. It is about 70 kilometers wide, bordering the continents and its topography. It generally resembles that of the coastal plain. It has a gentle slope of about 0.1 degree, that is 1.9 meters per kilometer slope. Sediments are transported across this continental shelf region by the currents. The third important feature is related to the continental slope. Continental slope is rather steep slope with 4 degrees, that is 76 meters per kilometer slope. It is following the continental shelf and it has a break in between. Some slopes are cut by the submarine canyons. These canyons are spaced closer together as the slope increases. Deep sea fans are also formed where these canyons empty out their sediments into the deep sea floors. The upper and lower continental rise comes next. These are usually smooth due to sediment cover. The slope of the upper and lower continental rise may be of 0.5 degrees, that is 9.5 meters per kilometers. The final part of the configuration is the deep ocean basin. The underwater zone bordering the continents is known as the continental shelf. It begins from the shoreline and gently slopes down to a depth of about 130 meters. The continental shelves vary in their width from almost 0 up to 1500 kilometers. The maximum is seen at the Siberian shelf in the Arctic Ocean. The average width of the continental shelf goes up to 75 kilometers. The edge of the shelf, called as the shelf break, occurs at a depth of 20 meters to 550 meters, averaging to about 130 meters. This break is marked by an abrupt increase in the gradient or slope to an average of about 4 degrees. In places like the Arctic region, the continental shelf extends up to a distance of 1600 kilometers. In some other areas, particularly those bordering much of the Pacific regions, it measures only 1.6 kilometers or less. The extensions of major rivers and their valleys of varying depths cut through the continental shelf region. The continental shelf region collects much of the sediments that are carried by the rivers and deposited into the ocean. The continental shelves are the most exploited oceanic regions commercially. It is here all the petroleum, sand and gravel deposits and fishery resources are found in enormous amounts. It is also the location where most of the wastes are also getting dumped. The shelves consist of vast deposits of sands, muds and gravels, overlying crystalline rocks and appreciable thicknesses of consolidated sedimentary rocks. Deep submarine canyons are sometimes found cutting across the continental shelf and slope regions. They are often found to be extending from the mouths of the major rivers of the continents. The notable rivers having such submarine canyons are the Congo, the Amazon, the Ganges and the Hudson rivers. The next important aspect is related to the continental slope and submarine canyons. Continental slope marks the boundary of the continental granitic mass and defines the boundary between continental crest and oceanic crest. Continental slopes are the longest and highest slopes on the earth. The slope may be straight or curved. The width of continental shelf zone may go up to 150 kilometers inside the sea. The water depth may range from 200 meters to 2000 meters. This is a zone of steep slope. The slope may range from 5 degrees to more than 60 degrees. In this steep topographic gradient, there may be no more marine deposits. Many of the sediments may directly move down into the deep ocean basins. The continental slope zone occupy 8.5% of the total area of the ocean basins. Within Atlantic Ocean, it is about 12.4%. Within the Pacific Ocean, it is about 7%. In the Indian Ocean, it is about 6.5%. Continental slope is geologically not belonging to the oceanic crest, but a part of the continental margin covered by the oceans. The most outstanding features of the continental slopes are the presence of the features like submarine canyons. Submarine canyons are steep sided and V-shaped valleys with tributaries similar to those of the river cut canyons which are seen on the lands. These are formed due to the continental rifting. The distributary channels are called as levees. Submarine canyons are located in transverse direction to the continental shelves. The fan-shaped deposits of these canyons, which are dumped at the bottom, are called as deep sea fans. These are distinct underwater alluvial fans. They are transported and deposited by the turbidity currents. Submarine canyons resemble like river canyons on the land, usually having steep rocky walls. They are also found along most of the continental slopes. Those of the Grand Bahama Canyon, which are thought to be the deepest, cut nearly 5 kilometers deep into the continental slope. Most submarine canyons extend only about 50 kilometers or less, but a few are more than 300 kilometers long. Modern submarine canyons vary considerably in their dimensions. The average lengths of these canyons have been estimated to be about 55 kilometers. Although the Bering Canyon is more than 1100 kilometers long, it is the world's longest submarine canyon. The shortest canyons are those of the Hawaiian Islands, which are averaging about 10 kilometers in length. Submarine canyons are characterized by relatively steep gradients. The average slope of canyon floors is almost 58 meters per kilometers. In general, shorter canyons tend to have higher gradients. For example, shorter canyons of the Hawaiian group have an average gradient of 144 meters per kilometers, whereas the Bering Canyon has a slope of 7.9 meters per kilometer. The next important feature of this zone is the continental rise. At the base of continental slope, the topographic gradient decreases to 1 degree or less, and the ocean enters into the abyssal plains or hills. This portion of the sea floor is known as continental rise. This is a product of deposition by turbidity currents, underwater landslides, and many other processes. The next important aspect is related to the features of deep ocean basins. The schematic profile of an ocean basin shows the following 10 features: submarine volcanoes, sea mounds, mid-ocean ridges, abyssal plains, abyssal hills or knolls, oceanic trenches, island arcs, fracture zones, guyards and sea mounds, and atolls. The abyssal plains lying at depths of 5000 to 6000 meters are nearly flat zones. This is mainly due to sedimentation. They are found mostly in the Atlantic and are absent in the eastern Indian and most of the Pacific Ocean floors. If there are no plains, then there may be oceanic trenches. Oceanic trenches are called as ocean trenches, which are very important features of the oceans. Trenches are long narrow depressions in the ocean floors. They reach a depth of about 7000 meters to 11,000 meters below the sea level. They occupy 1% of the surface of the earth. The following are the morphological features of the oceanic trenches. The width of the deep sea trenches varies from 30 kilometers to 100 kilometers, and the relief features go up to greater than 2 kilometers. The water depth may range from 5000 to 12,000 meters. This is the first part, that is the deep sea trenches. The second one is the abyssal hills. The width of the abyssal hills may range from 100 meters to almost 100,000 meters. The relief may range from 1 meter to 1000 meters. Most of the trenches lie parallel to the mountain ranges. There are about 26 major trenches in the world oceans. 3 of them are in the Atlantic Ocean, 1 is in the Indian Ocean, and 22 trenches are existing in the Pacific Ocean. There are numerous oceanic trenches beyond the continental rise. The greatest depths of oceans can be seen only in the form of ocean trenches. These are steep sided, long, narrow and hollow portions. They may be 300 to 500 kilometers in length and 30 to 100 kilometers wide with a depth of 6 kilometers. Initially their sides slope at 4 to 8 degrees and then goes up to 16 degrees to depths more than 10 kilometers. For those parts of a depression which exceeds 6,000 meters in depth, the term ocean deep is used. Ocean trenches are formed due to subduction of the oceanic crust. The faults which transect these ridges are called as transform faults. Ocean trenches are found to be parallel to the volcanic arcs in the oceans. These may extend 3 to 4 kilometers below the level of the surrounding ocean floors. The greatest known trench of the world is the Mariana Trench, which goes up to a depth of 11,022 meters, well below the sea level. The length may go up to 2,550 kilometers and the width may go up to 70 kilometers. The trench zones are characterized by complete darkness and unimaginable pressures due to the great depth. The pressure may go up to 16,000 pounds per square inch of the ocean floors. This is almost inhospitable zone of the deep sea for any life to stay and survive in the oceans. There is yet another feature within the ocean basins at the interior zones. They are the mid-oceanic ridges. Oceanic ridges are the most remarkable features of ocean floors. These cover nearly 23% of the Earth's surface. The mid-ocean ridges and the rises are formed in the zones of tension where the continental plates diverge. These ridges aerially cross to more than 65,000 kilometers of the deep ocean basins. These are the largest single topographic features in the world. These are considered as the world's largest mountain ranges existing below the marine waters. The mountains of oceans, which are called as ocean ridges, are not similar to the mountains of the continents. These oceanic ridges are mountain-like structures standing well above the deep ocean floors. The mid-oceanic ridges are in total 65,000 kilometers long and cover almost 23% of the Earth's surface. They exist as chains in the center of the ocean basins. These are rugged features. They stand 1 to 3 kilometers above the deep ocean floors. The most prominent feature of a ridge is its steep-sided central valley called as Rift Valley. A rift valley may be 25 to 50 kilometers wide and 1 to 2 kilometers deep in its profile. The rift valley of a mid-oceanic ridge is bordered by rugged mountains with the tallest peaks. These peaks may rise up to 2 kilometers above the sea surface, as also seen in some locations. Upwelling of the molten mantle rock has created these rift zones. The ocean ridges are composed entirely of basalts and are not deformed by any folding. The ridges are of two types, as active spreading center ridge and rise and inactive aseismic ridges. The active spreading ridges are about 1000 kilometers wide and 1 to 2 kilometers high. There may be also ridge valleys. The ridge valleys form due to the subsidence and downfaulting of the central portions where two plates are diverging. Oceanic ridges are traversed by series of fractures with steep sides running perpendicular to these ridges or rises. The next important aspect is related to island arcs. Island arcs are curved chains of volcanic islands. They are generally convex towards the open seas. Due to this nature, they are called as arcs. There are thousands of extinct volcanoes in the ocean floors. These regions are seismically active zones. Island arcs are topographically and structurally continuous features. These are formed when two oceanic plates converge and collide. The melting of the descending plate rises upwards as an extended magma to form the islands. Most of these eruptions are unnoticed. In some localities, especially in the islands, one can see the impacts as mud volcanoes and hot springs. Various features found in the ocean basins are not permanent features. Some parts of the ocean may be closing due to the plate movements and some parts may be expanding. This process of opening and closing of the ocean basin is called as Wilson cycle. Sea mounts and guyards are some more unique features in the ocean basins. Sea mounts are isolated, steep-sided submarine volcanic mounts. They may be 2 to 100 kilometers wide and less than 1 kilometer high above the sea floor. Very rarely they rise above the sea level, as we have seen in Hawaiian Islands. Guyards are flat-topped sea mounts. The flat top is created due to wave action. It is named after the Swiss scientist A.H. Guyot. Sea mounts are more than the guyards in the world. Nowadays, digital terrain models of sea mounts are generated from multi-beam sonar data. These methods are in a position to provide three-dimensional pictures of the ocean floors and their morphology. The last one is the vast ocean floor. The ocean floors is a very vast zone. It consists of rocks of geologically younger ages. The oldest rock is of Jurassic in age. Hundreds of millions of tons of sediments are emptied into the ocean every year by the world streams. Of the total volume of sediments, half of it lies in the continental shelves, slopes and the rises. They are called as terrigenous sediments. The rest are all available in the deep ocean basins. These are clays and oozes. They are called as pelagic sediments. The age of the oceans and the morphological features of the sea floor have been extremely important to the development of the theory of plate tectonics, ocean water distribution and circulation, control of marine life and the study of global climate. The oceanic crust forms the ocean floor. It consists of hard volcanic rocks called basalts. The continents lie above the continental crust. Continental crust consists of granitic rocks. Granites are lighter than basalts. Due to this, the continental crust is assumed to float on the mantle above the oceanic crust. And oceans are very typical environments where plenty of morphological features can be seen and studied. Oceanography is a very important subject of learning in earth science.